Digital electronics seems intimidating, only until you realize that every smart device you use thinks in exactly the same simple way. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition so you understand why technology behaves the way it does, not just how symbols are drawn on a circuit diagram. Most students believe digital electronics is difficult because it replaces continuous signals with abstract zeros and ones. But in reality, it exists to make electronic systems reliable, fast, and predictable. Instead of dealing with small variations and noise, digital systems operate using clearly defined states, which is why modern electronics depend on them so heavily. To see this intuitively, think about everyday decisions. A light switch is either on or off, a door is open or closed, and a yes or no decision requires no interpretation. Digital electronics works the same way. Logic gates perform simple decisions, flip-flops remember past states, and combinations of these elements allow complex behavior to emerge from very basic rules. At a deeper level, digital systems use binary logic to process, store, and transmit information. Combinational circuits respond instantly to inputs, while sequential circuits depend on memory and timing, allowing systems to count, sequence operations, and synchronize events. This is how processors execute instructions, how memory stores data, and how controllers manage real-time operations. On a larger scale, digital electronics forms the backbone of computers, smartphones, communication networks, and automation systems. From microprocessors and memory chips to control units in cars and industrial machines, digital logic enables speed, accuracy, and scalability that analog systems alone cannot achieve. In practical engineering work, digital electronics is applied when designing logic circuits, developing microcontroller systems, debugging timing issues, and interfacing hardware with software. These principles were formalized and standardized through the evolution of logic theory and semiconductor technology, making digital electronics the foundation of modern computing and embedded systems. Now that the intuition behind digital electronics is clear, the next step is to move into microcontrollers and programmable systems, where digital logic becomes flexible, programmable, and intelligent. And that's exactly what we'll explore next here at the Learning Studio.